Okay, today we're going to learn about factors, multiples, and we're going to do a couple review division problems. So, factors are any number that can be divided evenly into another number. So, if we think of the factors of, let's say, the number 3, what numbers can I divide evenly into the number 3? I can divide a 1 and a 3. Can I divide a 2? Nope. Can I divide a 4 or a 5? Nope. So 1 and 3 are factors of the number 3. If we take the number 6, what numbers can I divide evenly into a 6? I can divide a 1 and a 6. I can also divide a 2 and a 3. So 1, 6, 2, and 3 are all factors of the number 6. If we think about fact families, I could take a number 6, and if I had multiplication and division, I could build a number 6 by a 1 and a 6. I could also take a 6 and build it out of a 2 times a 3. So fact families for multiplication and division, we can build this number by multiplying these two numbers. We can build this number by multiplying these two numbers as well. So 1, 6, 2, and 3 are all factors of 6 because they all evenly divide into the number 6. Let's take the number 9. Factors of 9, well, I know that 1 and the number itself are always factors of any whole number. How else can I build a 9? Well, I can do a 3. 9 divided by 3 is 3. 9 divided by 9 is 1. 9 divided by 1 is 9. Let's see. What are the factors of the number 24? Well, I recognize that 24 is an even number. That usually means, I can say it always means, it can be divided by a 2. Again, 1 and 24. 1 and the number itself. What would I have to multiply 2 by to get to a 24? Or what is 24 divided by 2? It's 12. What else? Can I divide 24 by a 3? Yep, a 3. I would multiply that by an 8. Or if I divide 24 by 3, I get 8. If I divide 24 by 8, I get a 3. If I divide 24 by 12, I get 2. 24 divided by 2, or if I have 24 things and I make 2 equal groups, they'll have 12 in each group and there's no remainders. Am I done? Well, I don't think so. I know that 4 and 6 can both be divided into the number 24. Am I done yet? Let's see. Can I do a 7? 7 times 3 is 21. 7 times 4 is 28. So I know that I didn't land on a 24. So 7 is not a factor of 24. Factors are numbers that can be evenly divided into another number. And the key word is evenly. If you have a remainder, then that number is not a factor. So for instance, is 24 divided by 5? Can I divide 5 into 24? 5 into 2 tens? Nope. 5 into 24? Well, I know 5, 10, 15, 20. I can make 4 groups with 5 in each. And I would have a remainder of 4. That would be my remainder, and I need 5 to make a whole group. So if I have a remainder, that tells me 5 is not a factor of 24. So factors, again, when I think of factors, I think of division. What numbers can I divide into a bigger number? Now we have multiples. And multiples are maybe a little easier to remember because multiples have to do with multiplication. So, what are the multiples of the number 1? Well, if I skip count by the number 1, I'll end up with what I call our counting numbers, because when we learn to count, we learn to count by ones usually. So, what is the 6th multiple of 1? Well, 1, 2, 3, 4, 5, 6. If I do 1 times 6, I'll get 6. Let's try the number 2. If I skip count by 2's, of course I'll start at 0, which is not a multiple of 2. But 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 8, 10, 12. And we'll notice that all of these numbers are even because 2 is an even number. Let's take the number 5. What is the fourth multiple of the number 5? So essentially that question is, what is 5 times 4? If I skip count by 5's, well, I'm at 0, 5, 10, 15, 20, 25, all of these and many more. This goes on and on. Many more are multiples of 5. What is the fourth multiple? Well, if I start my number line at 0 and I go 5, 10, 15, 20, I've counted 1, 2, 3, 4 times, and so the fourth multiple of 5 would be 20. The second multiple of 5, for instance, would be 10, because the second one, if I create my own number line, which you're always encouraged to do, they don't always need to be made for you. You can make them on your own. We did that in class. Build your own, draw your own picture. And so these are multiples. We'll do one more. Let's take 9. So, what is 1 times 9? 2 times 9? 3 times 9? 4 times 9? 5 times 9 would be 45. What would be the sixth multiple of the number 9? So the sixth multiple of 9. Let's see. If I build that on a number line, I start here. 9, 18, 27, 36. I've gone 1, 2, 3, 4 places. 45 would be my fifth. So 5 times 9, 1, 2, 3, 4, 5 times 9 is 45. I think I wanted the sixth multiple, so what's 45 plus 9? Of course, every time I'm doing this, we know that multiplication is just repeated addition, so every time I do this, I just add 9. How many times did I do that? 1, 2, 3, 4, 5, 6. 6 times 9 equals 9 times 6, of course, and that would be 54. So multiples are literally multiplication. I think of factors as division. I think of multiples as if you're skip counting by a number, do you land on that number? So kind of a non-example would be, or will be, if I ask myself, is 7 a multiple of 2? Is 7 a multiple of 2? If I divide 7 by 2, can I do that without a remainder? No, we'll know that we have a remainder of 1 here. Also, if I do this on a number line, 2, 4, 6, 8, did I land on the number 7? Nope, 7 would be about right there. And I didn't land on that because if I skip count by 2's, I will never land on a 7. So 7 is not a multiple of 2. 2 is not a factor of 7. So as you know, division and multiplication are interrelated. Let's talk about division for a second. Because there were some problems on, I think, the first week's homework. So we just did 7 divided by 2, ended up being 3 with a remainder of 1. Let's try something like 57 divided by 3. Okay. In class, we did index card division, and so I asked students to, this is a little intimidating, or you get scared of these things when you look at them. You shouldn't, because you are very intelligent, and if you follow a few steps and you think about what you're doing, that the value of this 5 is not 5 1s, it's 5 10s. So in division, we keep our place value all lined up vertically, which is up and down, just like we would or we do when we subtract or add. So in class, we did Index card division is what I called it, and I made that up. You use any method you would like, but this is how I think about that. So I know it's 57. I'm just going to cover up this digit here. And now I just have 5 divided by 3. Well, if I skip count by 3, do I land on 5? No. I land on 3 and 6. So, my 1 in my tens place. The value of this is 10 because it's in the tens place. Just like 6 times 8 equals 48, or 48 divided by 6 equals 8. If I multiply this, I can check my answer. It's the same with kind of bigger problems, or ones that you have remainders with. So again, this is a 10 times a 3. If I have 3 tens, the value of 10 times 3 is 30. So let's say I started out with $57 and I wanted to share my $57 with 3 people equally. That means everybody got the same amount of money. I could give everybody, I'll just draw them. I'll just put people 1, 2, and 3. I could give everybody $10 to begin with. I could give everybody a $10 bill. And if I gave 3 people $10, I would have given away $30. Now I'm left with $27. Taking care of my tens place, I have an answer. I'm comfortable with it. It makes sense to me. So now I can move on. So where we started with it this way, now I'm just going to move this over here 1 column or 1 place value to the right. I'm going to put this down because I'm essentially at the end of the problem. I know from fact families and memorizing my multiplication table, my 10 by 10, that 27 now divided by 3, let's see, 3, 6, 9, 12, 15, 18, 21, 24, 27. So if I counted by 3 9 times, I would end up at 27. Now I've got 9 in my ones place. 9 ones times 3 ones is 27. In this case, I have 0 as a remainder. I could go around and give everybody another 9. And so everybody would get $19. Evenly, everybody would get the same amount. How can I check that? I can check it by, well, now I can multiply this top number, my answer, multiplied by this, and I should get this number. Let's see, 19 times 3, I'm going to use partial products. 9 times 3 is 27. Now I've got, should actually write this way. I like keeping track of what I'm doing, so 3 times 9. Now I've got the value of this again is 10. I have 110, so 3 ones times 110, or 3 times 10 is 30. So I multiplied 3 times 9, 3 times 10. If I add these together, I get 57 as my answer. And that is the number I began with. So I think the example I used a second ago was something like this. 48 divided by 6, I get 8. This number multiplied by this number, excuse me. If I had $48, I wanted to share it with 6 people, everybody would get $8 with no remainder. Means we wouldn't get any change. Let's see. Let's try one more. You can use any of these methods that you are comfortable with. I like this is kind of like the big 7, but 361 divided by 6. Try another one. Let's see, index card. So I know this is 361 because I just wrote it. I see the problem on my paper, but I'm going to make it a little less, I don't know, that looks like a big problem to me. So I might just help myself and cover that part up. I know this is 300s plus 60 plus 1, 361. But I'm going to, can I divide 3 by a 6? Nope, can't do that. If I only have 3 things, I can't make a group of 6. So you'll remember from class I talked about an invisible 0 a lot to keep track of my place value. So I can't really do anything there. If I go over here, 36 divided by 6 I can do. Of course I still know this is 361. 36, that of course is 36 tens. 36 divided by 6. I know from my fact families and my doubles, facts, and multiplication, 6 tens, again this is in the tens place. We're going to write neatly and we're going to write everything vertically so we can keep track. 60 times 6 is 360. End up with 1. So, say I have $361, I want to share it with 6 people. I can give everybody $60. And if I give 6 people $60, 6 times 60, I'll end up giving away $360. I'll be left with $1. Now can I divide 6? So if I'm here and I took care of that and then I go over here, do I just put this 1 up here? Can I divide 1 by a 6? If I have $1, can I break it up into 6 equal parts? Possibly, but 1 divided by 6, I can't do that. So that's actually not an invisible 0, that's going to be a real 0. So what's my remainder here? It's a remainder of 1, or I'll write this as 60 and 1/6. So everybody would get $60 and 1/6 of a dollar. 1/6 of a dollar is something like 15 or 16 point something cents. So 60 remainder 1, or 60 and 1/6. We'll do some more division in a week or 2 or 3, but I know I put some of that work on last week's or the previous week's work, and we'll continue to look at this. That's it for factors, multiples, and division. Please let me know through email if you have any questions, and have a good day.